but I
Well,
don't really mind, to be honest.
well, so you see, the mathematics is a way of describing things, okay? Something abstract
Yeah,
between numbers and functions. But the chemistry and physics are dealing with real objects. Using
yeah, that's right.
mathematics to some extent to use mathematics, especially in physics, we use a lot. We can't you can't do physics
Oh, physics.
with mathematics, but
Yeah, yes.
in chemistry, in many case, in many times, you are actually to know the names, the naming system of the chemical, because there are so many different
Yeah,
molecules, right? Compounds, what they call compounds. And
compound.
yeah, that's right. Traditionally, when you study chemistry, you have to learn how to name this system, right? For example,
Mm.
if you have the carbon dioxide, so what does it mean? Di means two, right? So first of all,
Oh,
you have
yeah.
to you first of all you have learned the naming system. Okay, you have learned how to count again, right? You use a kind.
Mm.
How about the three? How to denote the three? What do you think? Like,
Three,
yeah,
try,
yeah, try three. How about four?
quad,
Quad or tetra? Or tetra. So
petro.
tetra, yeah, tetra. So if you want to know the if you want to build your basic knowledge of chemistry, you can do two things. One is to know the whole system of how to give the chemical names, right?
Yeah,
Because by the time when teacher actually teach physics, teach chemistry at the school, they just assume that I just say that name once, everyone should remember, right? But you can't, you
yeah,
can't.
yeah,
So this is something
like,
you can do beforehand to get familiar with how different chemical and compounds are named, right? This takes some up to you.
wait, how they're named? Wait, that it's like Latin, right, or something?
They sometimes use Latin, but sometimes they create some English by change the suffix or prefix and suffix. So
Yeah,
from suffix and prefix, just like making new words. Okay. So from
yeah,
this
pretty much.
suffix and new words, you can get some idea about the chemical all about.
Yeah,
Of course, there are many exceptions, right? Unfortunately, and this naming system work for many chemicals, but sometimes there's exceptions, all right?
yeah,
But this is just descriptive. You agree? They didn't
yeah,
tell you by starting the naming, you don't know how they react, how do they interact. Okay, when they put the two chemicals. So basically, when you study chemistry, is to know that when two seemingly different material meet, and sometimes they change into a different material. Okay, this is called a chemical
oh,
change.
wait, is there like a formula to like determine what like new
Well,
element it will turn into?
Well, just go to
Like,
whiteboard. Yes, if you want to know, do you want to starting from naming? We can start from naming. Chemical have different proper naming.
yeah, yes, because at school, yeah, we we're learning like
Yeah,
chemical reactions and those stuff, but yeah, we're not supposed to learn it at school. But I was just like wondering, like, is
yeah,
there this way that you can figure out, like,
yeah.
which two
For example, a
become
chemical
something?
have name.
Yeah.
A chemical. When something chemical is actually in the chemical material. For example, right?
Mm,
Chemical material could be the mixture, right? Could be many things mix them up, right? So the mixture.
yeah.
And it could be just single chemicals, okay?
Yeah.
The same material, what we call the same critical, they just have the same chemicals. They got more than one. The mixture has more than one, so it's more than one chemical. Sorry.
Mm,
You see, depending on what you can't, you have to get. This is how to describe chemical material. But it's just for the non, it's just uniform material, just one chemical. It's just one chemical, right? One chemical.
yeah.
In this case, one chemical normally will have we have some knowledge. So how about there's a formula they call the common name. You got a common name. Common name. Okay. They got other also. They got also chemical name. They have this may or may not the same. Okay. It has a chemical name. In chemistry, how we call that? Okay. Chemical name. Sorry, not name. Name. Sorry. So you can imagine that you can common name and the chemical name
like iron and gold and those stuff.
That's right. When you go, that's right. Even from the elements, okay, the simplest chemical, the simplest chemical. So chemical itself can be divided by the just how to say the element. See, the simplest chemical is element.
Yeah.
Elements is actually then you eventually we realize elements is actually atom. All right.
Yeah.
And then got compound. See the compound.
Yeah.
A compound is just more than one atom. More than one atom.
Yeah. More than one type of atom.
Yeah.
Yeah.
Yeah. And actually, these are the same thing, but because of the traditional chemical naming, and they put the compound and the molecule into different category. Another is called a molecule. So
molecules are like two different. It's like two elements mixed together, right, or something.
Well, but compound is the same. Actually, so in this case, so there is a chemical way to divide that chemicals, right? So let's just say you this is something we can go some. We have good beginning, right? Before we start run, we have to make this common. So that's how you categorize that in chemistry, okay? In chemistry course. In the chemistry course, you call that the chemicals, the same chemicals as contain the element, compounds, and molecule. Okay, but in physics, we just call them what we call them. We call it element is actually atom. All right, atom. So that's why you have to be careful. When we talk about, when you study chemistry, when they say element, actually they are talking about atoms, okay? And what is a compound? We don't care.
Compound is like two, like more than one type of atom.
Wow, so does molecule, you see? So when we start molecule.
On a molecule, they're like stuck together, but elements, they're like actually like separate. Does that make sense?
No. That's, don't get confused. So that is something I dislike in chemistry. Do you understand? It took me a long time to know what is a compound and what is molecule when you read the chemistry book. All right. They are molecules, but this compound is made by ionic bond. See, ionic bond. When you have the ion combined together. Ionic bond. Did you talk ionic bond?
Ionic bonds are like the two different charges, right?
That's right. You do electrical force, right?
Yeah.
That's called compound. And but for the molecule, that this is made by what? Can you guess?
Covalence.
Covalence. Okay.
Oh.
Covalence bond. So this is a typical nuisance in the chemistry. Do you understand? Because historically people know that these such molecules, the molecule when atom form the molecules, right? They can either form the chemical bonds, ionic bond, or sometimes they can form covalence bond. So traditionally, people say, well, those molecules, those material chemicals made purely by ionic bond should be called compounds. All right, and those material made by covalence bond should be called molecule. All right. However, this is nonsense. Okay, this naming, this
What?
distinction is nonsense, because if you study chemistry, go on.
How? Okay, never mind.
We
Oh, it's
don't-
an ionic
we don't
bond and
care.
covalence bond that goes under physics.
It is just how atom to form the molecule, right? So at a molecule level, this is just nonsense. For example, if you have two, I just draw the atom. Atom could be described by the ball. Do you remember? Atom could be described the ball. For example, the water or carbon dioxide. Can we go to carbon dioxide? This is carbon. Can you see? They are atoms, right? And they form when they form the molecule. Can you see when they form the molecule? Okay.
Yeah.
And then they just three balls and join together. That's it, as simple as that. Do you understand? So this is how the molecule. So in physics, we just call it molecule. Okay. We don't call because in this case, this is a simple molecule, right? This is very simple molecule, and therefore that the interaction between this simple can be just covalence. Okay. However, it also possible that the molecule is made by different atoms, right? They will just have the mix. Some chemical bond is a covalence, others ionic, right?
Yeah.
That could happen because you see.
Wait.
Yeah.
Oh, can you say that again? Some.
You see, what I'm talking about, this is very simple chemical, right? It's called CO2. Can we write it down here? That's
oh yeah, CO2, yeah.
That is CO2. So that is a chemical formula. That's CO2, right? CO2. And this is hydrogen. This is hydrogen. This is carbon atom. Can you see that? Yeah. So, and there must be an attraction between them. Otherwise, they cannot form the chemical, cannot form in the molecule. Can you see that?
Yes, that's right.
So, depending on the circumstances, this chemical bond can either be covalent or ionic. Do you agree?
Yes, that's right.
But sometimes, some large molecules, some part can be, they can build another molecule by either covalence or ionic bond.
Yeah.
Right. So, for example, if I just make such thing, this is a hypothetical material. For example, if we have if you put more than 3 molecules, for example, we just built another molecule here. We can build other molecules. If other molecule, we add other molecule, right? So in this case, and there's no guarantee that the bond is always covalence. Okay.
For molecules.
For molecules, that's right. Yeah,
that's right.
So therefore, this, in my opinion, it's up to you. Okay, if you want to study the physics, if you want to study physics, right? Then we just simply call molecules. Okay. But if you go to if you choose in chemistry course and you have prepared that sometimes the teacher will call these chemical compounds and other chemical called the molecules, right?
Yeah.
Okay.
Wait, so like, are there like certain like elements that just connect to each other using covalence, to some that just connect using ionic?
Yes,
like,
that's
are there
right.
certain properties? That's
possible. Yeah. Yes. Pure. You are right. There are molecules that purely connected. For example, the good example is the salt. Okay. You know the salt.
Salt. Yeah.
Yeah. Salt is been made by
sodium.
2 atoms, right? One is sodium.
Sodium chloride.
Yeah. Sodium chloride. Chlorine.
Yeah, chlorine.
That's right. Yeah. So in that case, so in this case, it is indeed that in this case, in these particular molecules, and it is made by 2 atoms, and the chemical is just due to the electrical force.
Yeah.
So electrical force, that then you can call this is that's right. I just make a sure when you encounter this molecule, you can call it compound. Okay, following the
Yeah.
chemistry's convention. But when you study physics, you don't have to. Okay, you don't have
Yep.
to. And okay, there's another thing you need to know. For each chemicals, you have to know this chemical formula. There's another thing called chemical formula, like the one I wrote here, the chemical formula. A chemical formula is just it's just description of what the material are. For example, X, Y, Z. You put 3 different atoms together, and you have to make sure they have different. You have right amount. You have right amount of chemical there, right? If you don't write anything, it just means 1. Okay, if nothing there, it's just 1. So this is just the number of atoms. So then this is a number of atoms.
Yeah.
Okay.
Yes, that's
Makes
right.
sense. Number of atoms in a molecule, in a chemical, in a molecule, just a molecule.
Yeah.
Okay. But they just categorically call this different. They call it chemical. Chemical is an adjective, right? But chemical can be also used as just a molecule, right? They just call it chemical. The chemical, chemical, right? So that's acting as a noun. So to be careful, that's something to say different chemicals, right?
Yeah.
So you can see that when we study chemistry, we have to you can ask some question, I can answer you. Okay, instead I just tell you story. The story is too long, right? We have to go back to as early as ancient Greek, when people think about what is elements. This is keyword here, the elements, right?
Elements.
So elements has been mentioned by people since ancient Greek. Okay, elements is something smaller, very small, the smallest stuff, which can be used to build a more complicated or larger size material.
Yeah.
By the way, what is elements in mathematics? What do you think? What is element? Yeah. If you talk elements in mathematics, what are they? Elements. Just think about it. You have studied math for so long. Elements in mathematics, what
is it like those letters? No, never mind.
That could be one of the notation, yeah.
Yeah.
But in mathematics, we study 2 issues, right? Yeah.
Yeah.
We study numbers. Do you agree?
Yes, that's right.
And then we study shape, right? Geometry.
Geometry. Okay. Yes.
So number and shapes can be simple and more complicated, right? For example, the number can be large. Can you see because the 218 is a number, right?
Yeah.
And the shape can be also, as simply as a triangle. Do you agree? Could be a triangle.
Yeah.
Okay. But or we just use a more complicated one in this case, not a triangle this time, because how to call that is this shape. They have 5, we have 6, 1, 2, 3, 4, 5, and 6. What do you call that? You will use, can you say hex is 6? Okay. Can you say that means 6? You can, in chemistry, we use this hex to represent the 6 as well. Okay. So in other words, if you're interested, if you are interested, we can go to the naming system next time. Okay, one by one, how to give a proper name for different chemicals.
Yep.
Let's just return to the question. Do you think this number and shape are element in number and the shape?
I don't think. Well, I haven't learned it yet. I think.
No, I don't think so. Well, this 218 can be written as 200, right? Plus 18. You agree?
Yes.
There are many ways. There are many ways to separate them. It could be 20 plus, or could be 200 to 100.
Yeah.
Okay, so can you see the number getting smaller?
Yeah.
Or 40, or that's 18. 18 is what? It's 9 plus 9. Can you see that?
Yes.
Now, if we just consider the number, when you found the element, you have to give the proper definition. So what would be the smallest integer?
1.
That's why. So that would be simply 1. Can you see? 1, and just multiply. You just give the sum, okay? So so in that way, you go to the elements, that will be the 1, the integer. Can you see? They got 1 plus 1 and so on. There are many, you just separate this large number into the element. Can you see? So in this case, 1 is element.
Oh.
Does that make sense? Element
Wait,
is
so what else can be?
Go on.
Oh no, you can continue.
No, you can ask a question anytime. What is your question?
Or so is like 1 the only element?
Well, if the integer can any integer smaller than 1? This is good question. See, can any integer? No. Smaller.
Wait, negatives.
Yeah.
Negatives.
Smaller than
negatives.
1.
Yeah, they're like -1.
Oh, then you have to come. We have make them rewrite the game. Positive integer.
Positive integer.
Yeah, we have. Yeah,
that there's none.
So that is smallest integer. So any is, do you agree? Right? The answer is no. Okay. The answer is no. Okay. Yes. So any positive integer. Okay. So in other words, any positive integer. It's just one example. Can be obtained. Okay. Obtained by adding 1. Can you see? Adding many 1. Yes. Okay. Yeah. N1. Can you see? Is that is element, isn't it? So in this case,
so element is basically N1 or just 1?
No, N multiply 1. Can you see? You just N
multiplied by 1.
N1. I just read this. N.
So that's
1.
So that's basically
this is 1. This means N1. Okay.
So that is element. That is an element.
The element is not very abstract. Element can be described something simple, basic, but elements in this case, we are looking for the smallest unit for something.
And that is.
Yeah.
That is 1 in this case of math.
In this case, the number 1 is just 1, right? Just 1.
Yeah. And
how about the geometry? Do you think there's other simpler shape than hexagon?
Yeah, like triangles.
Of course. You can divide that into many triangles. That's right.
Yeah, squares and those stuff.
Yeah, you can start. You can. This is start with. This is how to trapezoid. Okay, it's a trapezoid, and you can either continue to make it identical. This is how to say isosceles, right? 6 isosceles.
Yeah.
So if you cut that into the triangle, then the smallest triangle will be called the element in this case.
Oh, okay.
That's how we divide elements. Also, for example, when we nowadays what is the element for the money in Australia? What is the smallest coin?
Cents. 5 cents.
5 cents. Right. Physically, it's 5 cents, right? But if you say, well,
actual money, that's like,
I'm talking about physical.
100th of a cent or something.
It is also, but 100 is that element. Do you agree? 100 is a big unit. You can count 100. So that's 100 is not element. Okay, for example, let's just.
How about like 0.0 0.01 or something.
Oh, that doesn't make sense. You must be talking about unit. Okay, this is called unit. You can go
1
that
cent,
one in
maybe.
this case means unity. Is a unity. Unity is just integer, the smallest number in integer.
Yeah.
If you use $100 as a unit to count, you are fine. But the element, it is not element, right?
Yeah.
That element.
That makes sense.
Yes. Okay. So in geometry, we still have elements. Okay. Also, you can, for example, if you have the rectangle, so is a rectangle the element of this type of shape?
No.
No. Well, in the first place, we can put into the two triangle. Can you see?
Yeah.
And this just continue. All right. It's just continue. Actually, the idea of elements was first put forward by this Euclid. Do you know the Euclid?
Yeah. We talked about him before.
Euclides. So his theory is called Euclidean.
Yeah.
And his first book, his famous book, is called Elements.
Elements. Yeah.
Yeah. But the elements there is a mathematical element, not a physical.
So he's a mathematician.
He's a mathematician there.
Yeah. Okay.
So everything with geometry, this geometry, this actually is geometry.
Geometry. Yeah.
Geometry, when you start shape, in math, that's actually this area, the branch is called the geometry, right?
Yeah.
And the geometry started from Euclid, and his book is called Elements. Okay. So they're talking about the triangle and the straight line, and for example, the parallel line, perpendicular line. These are they're talking about in Elements.
Yeah.
But if you go to the detail, the last chapter of this book, you still can Google this book. This is first textbook in mathematics we still know today.
Oh.
Okay.
Yeah.
The Pythagoras just have just one theorem, right? But in Euclid's elements, there are many theorems. There are many theorems. The last chapter, if you go to the last chapter of this book, you will see something very is relevant to chemistry, right? Even to atom. So in last chapter, they are talking about what is the last chapter? They call the Platonic solid.
Oh, Platonic solids.
Have you heard of Platonic?
Yeah. Yeah, we talked about it before a bit.
Yeah, that's right. We talked about before. Solid is just a 3D shape, okay? That is a 3D shape.
Yeah.
3D shape, not 1D, 3D shape. And this is not only the physical, mathematical idea, it's also philosophical idea. Because how many polynomial solids did we discuss? Do you remember?
Platonic.
Yeah.
Oh no, I had to research it for
1, 2, 3, 4, 5. 5. There are 5. There are 5 3D segments. What are the 5?
Was there like this triangle thing?
No, triangle is a 2D. So this is 2D shape. Can you see this?
Like the square-based pyramid?
Yeah, pyramid and tetrahedron. I write down the 2D shape. It's 2D shape. But if you go to let's go to next page. Yeah, we can. So don't think chemistry is come from just modern. Don't you see it's boring if you just study the textbook, right? Because chemistry is that if you start chemistry without knowing this background, you just memorize things teacher told you. For example, they are equal size. If in atoms if they have 5 protons, they must have 5 electrons, right? If the and such, it's boring. But if you want to know more, if you've done some background, that will help you to understand. Okay, so in this particular case, can we just write down how many Platonic. Just study how many Platonic sonnet. That is relevant to the elements. Okay.
Yeah.
So there are 5. So actually, these 5 elements. So that actually there are 5. There are 5 elements. What are they? They have proper name. One is called Earth.
Earth.
Yeah. Or just soil. Otherwise, you think it's a
Soil.
planet, right?
Soil.
Soil.
Oh,
okay?
yeah.
Soil.
Oh, yeah.
And then is water.
Yeah.
And the third one is air.
Yep.
Fourth one, can you guess? What are the elements in nature? When
Rock.
ancient, apart from water, air, soil, any other thing they are thinking basic? Are the basic?
Oh, is it rock?
Rock is part of the soil.
Wood.
Okay. Think.
Wood.
Wood. Wood is a part of soil. So, well, it's a combination, right? It's not essential.
It all earth.
Now it's got fire.
Oh.
Have you heard of fire?
Fire?
Yes.
Oh, yeah.
Because in ancient people saw, lightning, okay, and sometimes they go to bushfire. Without fire, they cannot cook. They couldn't cook, right? Without fire, they cannot make, they cannot using metals to build sculptures. They call it casting. Do you know the casting? They use high temperature to melt these metals, and like a copper, like brass, copper, iron, aluminum, this kind of thing. So fire is essential. So in Platonic time, people think these are the elements on Earth. These are the elements near where we live, right? That is the 4 elements. But in addition, Plato proposed the 5th one. Can you guess what is 5th one?
Flesh?
No. They called ether. They called ether.
Oh.
Ether is the 5th element Plato considers as Plato thought it should be taken into account, right? And the original Latin name for the ether is Ae. They have Ae. They mean the same thing. So this is a material. They believe that is associated with because people have believed that those stars are heaven, moving in the heaven, right? So ether is a heavenly star. Okay, so that kind of material cannot be found. Ether cannot be found on the earth or near the earth, right?
That's like dark matter sort of thing.
Dark matter, no, it's a good idea. These still have debate whether ethers still exist. It's non-story about the ether. Okay, ether is an ancient element. People used ether. Actually, Plato. You know this guy. This you know. These Platonic come from the philosopher. Is called Plato. You know Plato? Yeah.
Yes.
So his idea is called Platonic. Okay. That's why. So this is his idea. So Plato thinks that there are 5 elements that can explain everything in nature. Everything in nature observed is a combination of these 5 elements. In his day, there's no. So the Plato probably into 400 to 300 BC, right?
Yeah.
Roughly. So you can see that many thousand years ago, Plato started to consider what would be the fundamental or smallest elements. Okay, because he himself is a philosopher, right?
Yeah.
In the meantime, he also admired the Pythagoras. Pythagoras is not only the philosopher, but also the mathematicians, obviously, right?
Yeah.
So because of that, so Plato proposed that each element, each of these, hypotheses must be hypothetical material element called elements must be have proper shape.
Yeah.
So that's why they draw this shape. The first one is cubic for the solid. By the way, how many faces for the cubic?
6.
Yeah, 6 faces, right? Yeah, so that's why I say the cube is called cubic. Also, you can the cubic also can equal how we use 6 now. Can you see?
Mm-hmm.
Hexahedron. Hexahedron. That is a proper name.
Hexahedron.
Yes, hedron is there. Just the same as cubic. Same as cubic. Okay. So this number of face. This is a number of face.
Yeah.
It's 6, right? It's 6. How about water? Oh, water is complicated. How about how about fire? Let's go to something simpler. What is fire looks like? The flame. You know, if you go camping, right? If you have to burn something outside.
Like a triangle, yeah.
Yes, like this is not triangle. This is 4 triangle actually. 4 triangle. Can you see that? What is the name for that? How many faces for this this shape?
4 faces.
That's so not 6, 4.
Quadrahedron.
Yeah, that's a tetra. That's how we can use this knowledge to start chemical names. All right, it's called tetra. Tetra means 4. Okay, tetrahedron. Make sure it's correct. Not N. Okay, that is a fire. That's the shape of fire element. Okay, of course, presumably these shapes are very small. Okay, unless you want, but how small they didn't say, because in those days nobody can measure the size of this element, right? Mm-hmm. Now, how about air?
Sphere.
Fire? No. Air is something like this. You just put the 2 tetrahedron together. Oh, not tetrahedron. This has 80 sides. How can we draw that? Yeah, 8 sides. Can you see that is I should use. We can't see other side. I just do this one. So first of all, we make the square, okay, and then we make this pyramid. You know the pyramid?
Yeah.
You put you made the 2 pyramid upside down and put them together. Can you see that?
Yeah.
How many sides can you count? Each pyramid, apart from bottom, how many sides per pyramid?
Pyramid uses 5.
No, 4. 1, 2, 3, 4. Yeah. So they got the surface. I'm talking the surface, the face. Yeah. Okay. They got 8, right? Yep. In how to describe the do you know October? What does October mean?
Oh no, 10. It's actually 10. But like 2 other.
No, October means 8.
Oh, octa.
Yeah. Do you know why? Because they deliberately put some king's names in between June and July and August. No, between August and September. Sorry, between the June and July.
Yeah.
One moment. The octa means 8, but October means the 10th month, right?
Yeah, apparently you're supposed to be 8, but then like 2 months got over.
Do you know why?
Was it like Augustus and
Yeah,
Ulysses or
that's right.
something.
They put some a king and queen's name in between. All right.
Yeah.
So that chain that makes October sounds like sounds as tens now, but actually it represents
Yeah.
8. Anyway, this particular solid is of 3D shapes called octahedron. You know, octahedron,
Octahedron, yeah.
octahedron. And by the way, some if you go back to the modern study, modern physics, right, you will find some crystals have this octahedron shape. If you can see the atom, if for example, I could give you example. For example, if you put a 3 oxygen, okay, you put a 3 oxygen, make a square,
Yeah.
okay, then you put another metal ion. For example, it just use different color. If you can put a metal in at the center, all right, and then
Yeah.
if that is the case, then the chemical bond will form. And in addition to this, called a planar, these 4 atoms on this square, this is called a planar. Can you consider this just like a flat plane? There's a 5th and 6th atom can be formed at the top and another at the bottom. Can you see that?
Mm-hmm.
Now these are the real molecular structure of the crystal. Okay, like
Yeah.
the chemical so if you join them together, can you see that? If you use a dot line to join them together, so what shape do you obtain?
Wait, say what again?
If you join these atoms together by this dashed line, so what is the 3D shape we obtained?
If you join these together.
Yeah, join them together. Can you see that's 4 corners?
Oh, cube.
It's not cube. No.
On a rectangular prism.
No, octahedron. These are octahedron. Can you see? That is real crystal. That's a real molecule.
Mm-hmm.
Okay.
Whoops.
So later on, of course, today we are discussing ancient idea. Today we are discussing ancient ideas from the Plato, right?
Yeah.
Because the reason I discuss this background is because that elements actually were discussed many years ago, several thousand years ago, by Plato and his followers, and including mathematician it's called Euclides. Okay, you know the Euclides is the great mathematicians. Okay? Yeah, and so many geometry we study nowadays are still Euclideans. Okay.
Mm.
Of course, just in the 17th and the 19th centuries, that there's someone called Riemann, who proposed that geometry can be studied different. The geometry can be studied different from Euclideans axioms. For example, when we study the 2 parallel straight line, right? Euclideans say these 2 straight lines were never joined. Were never, right? Were never.
Oh, parallel lines, yeah.
Yeah, but according to Riemann, okay, if you wish, we'll talk about mathematics history as well, because Riemann geometry is called a non-Euclidean geometry, and this is possible. The 2 straight line, parallel straight line, eventually can join, right?
Well, how?
Oh well, that is not issue. So if you just consider, so if you want to know this one, if you just consider, yeah, it's good. If you ask a question, I will answer you. For example, if you consider Earth, can you see this is Earth, all right? If you call it Earth, and you just let's just draw something for you. So this is equator. Can you see this equator, right? This is 3D diagram. This is 3D diagram, okay? And this is North Pole. See, this is North Pole. You agree? Now, if you draw the straight line from the north to south, you get this this curve, right?
Yep.
Okay. another person which is slightly away from you, okay? And you, because this Earth is so big, so they are trying to draw some parallel straight line. Can you see that?
Yeah.
However, if you extend that straight line, what you will have? They were joined at the pole because the surface is curved. See, the surface is not flat.
Oh,
It's
you mean
curved.
like parallel line, like
Yeah,
on the Earth. Oh,
it's curved
yeah, true.
space, curved surface. Okay.
Yeah.
So the two straight line, parallel line will never meet. Is that correspond the flat? You see, if you talk something flat, that's okay. Can you see that? If something is flat, these two straight line will never meet. Do you agree? Will never meet. But
Yes,
this
right.
is flat. Yeah. Okay, this is flat. This is called flat. It's flat space, flat surface. So you can see this is what called Euclidean geometry. Euclidean geometry.
Yeah.
And this called non-Euclideans. Euclidean.
Yeah.
Geometry. All right. So there are many things. This is related. Okay. When I talk about elements. Okay. How about water? Just finish that one. How about water? Water is very complicated. Water. I just read the name here. That ISOSA hadron.
Isohedron.
Yes. Isohedron is a large number. I can tell you. It's 20.
20.
20. The 20
also
surface.
it's looking a bit like a sphere right now.
Or it looks like space, but they made by triangle though. They got made by triangle. So made by 20 triangle.
Yeah.
Triangle.
Yeah.
So I can draw a few of them. Okay. Can draw a few of them. So this is triangle. So this is one. Can you see? There's one. There's two.
Yeah.
And there's three. There's another one. Oh, I hope we can draw that. That's three. That is three triangle. And that is another one. It's hard to draw, okay? It's harder to draw. You know that it's a 20 triangle. That is water. Okay. Almost the surface, almost like a sphere, okay? But ITER, how about it? This is made by 20 triangle, small triangle.
Yeah.
Okay. How about ether? It's called E. E for ether. It's
going to be crazier, isn't it?
Ether is not. Ether is that's D. When you say D, it's a 10, okay?
Oh, D.
Dodecahedron.
Yeah, okay.
Dodecahedron is actually 12.
Dodecahedron, yeah.
Okay, yeah, dodecahedron. Have you heard that? We have particular taste intestine. After your stomach, that short part of the intestine is called
duodenum.
Duodenum, yeah, that's right. It's just 12. 12. This means 12. I write down.
Oh, okay.
Yeah,
that's cool.
Dodecahedron. Yeah, that's wrong. Yeah. Remember, this is idea 2,000 years ago. All right.
Yeah.
And if you want to draw that, it's not the football, but similar to the football, soccer. But they got each element is have five sides. What do we call that?
5 sides.
Yeah, the Department of the Department of Defense. What is the building looks like?
Oh, the Pentagon.
Pentagon. Okay, that's Pentagon. Yes. Okay.
Yeah.
That's right.
Yeah.
So this looks like this because this is so made by Pentagon. Okay.
Yeah.
Pentagon.
Oh yeah.
So that gives. So this means 3, and this means 5. Okay, and this means 12. You can see that. Of course, they are all hypotheses. Do you agree? So this is just remain at hypothesis. This is Plato's hypothesis. So this is Plato's Play
Yeah.
hypothesis. Okay, not necessarily real or true. Hypothesis.
Yep.
Okay.
Hypothesis. Yes.
But to return to the question, why did what do you think? Why did Euclidean spend his last chapter to discuss Platonic sonnets? Do you know why?
Yes. They're like, I guess they're a bit like atoms.
Yeah, they think this is apart from in his element of geometry, or he also include Platonic sonnets because he thought that if he can include this something real, and his book will not just talk about the mathematics but also the whole nature, right?
Yeah.
However, eventually now, do you still think that these 5 elements are real, are true?
Well, I mean,
So
no,
what
not
is
really.
air? So talking about air, what is air made of?
Air is basically gas.
Yes, air is gas. Okay. So in air, how many gas? How many gas? So what is air? Modern idea.
Air is like oxygen.
Yes, it's
like
gas. It's a gas. It's a gas. You got oxygen. Do you mean oxygen? Yes.
Yeah, oxygen.
Got hydrogen. Do you agree?
The hydrogen. Is it nitrogen as well?
Nitrogen the most. Nitrogen the most.
Yeah,
nitrogen gas.
A lot of nitrogen.
They're all the gas. They're all the gas. Okay. Of course, there are other things. There are other trace element. Okay. Actually, the carbon dioxide is very small. It's probably 0.001%.
Oh, okay.
Very small carbon dioxide. But the nitrogen is a quarter, right? Something like a quarter.
Oh, then the rest is oxygen.
No, you can probably another 3/4 or something. You can Google that. Doesn't matter. You can Google the person. But my question is, do you think air is element by modern standards?
No, it's not.
No, it's
not.
No way. So no way. The air contains so many different chemicals, right? Each molecule is called a chemical, right? So this is not right. And how about water? Water is the smallest element?
No, it's not.
No, it's not. So the Aristotle is wrong, right? So when we talk about water, actually we're talking about two molecules, right? We have 2 molecules. We got oxygen and hydrogen. Okay, we got two hydrogen. We got 2 hydrogen. So eventually when you put them together, and actually, what type of bond do you think they join together? Oxygen. Ionical or covalence? Can you just guess? Doesn't matter, just to guess.
Covalence.
Covalence, yeah, covalence bond. Yeah. Or they have in this particular case, they have proper name. It's called a hydrogen bond. Hydrogen bond with the other atom in a special way. So therefore, there's a third category of chemical bond. It's called a hydrogen bond. Okay, hydrogen bond is similar to covalence bond, but slightly different. That's all. So that is why we say that there are 2 major types of chemical bond. So this particular bond is called a hydrogen bond. Hydrogen.
Yeah.
It's slightly different from covalence bonds. We can go detail, okay, after we study this nature. So we know that after all, as a whole, the so-called 5 elements are not necessarily right, okay? So because they can nowadays we have many. Yeah. We have physical way, we have chemical way to separate this material. Okay, they are not pure material. Okay, they are made by different atoms. But this idea took a long time. Okay, by the way, this is just one of the explanation of the elements in nature. Another great physicist, not a physicist, but a philosopher, do you remember, is Democritus?
Democritus, yeah.
Yeah, Democritus, okay.
Yes.
Democritus is such that his ideas differs from the Platonic ideas, Okay, they belong to different group of philosophy in ancient Greek. Okay, and he put forward his idea of atom. See, do you remember the atom in Greek? What is A? What is atom? Do you remember? A means not.
Or not be able to divide.
Divisible. That's divisible.
Not divisible. Yeah.
Divisible. So is that divisible is something you cannot cut anymore, cut into smaller anymore. Do you remember that diagram I drew to you? So if you just cut the rope, okay, or any material, if you or you even go to straight line, okay, you got to say this probably is just a material, and the length, for example, can you just 1 meter? Can you say just 1 meter?
Yeah.
If you cut into half, what you obtained?
50 centimeters.
Yeah, that's 0.2, right? 0.2 meters or half meters. Can we see?
Yeah.
If you cut it half again,
there's 0.25 meters.
Can we use a fraction? Use your fraction.
A quarter of a meter.
A quarter a meter. Okay. Can we go further? Oh, this is too big.
8.
Yeah, it's yeah.
Then 60.
Yeah. It's half. Can you see?
30 seconds, 64.
Yeah.
100. 120.
So eventually you cannot draw it. Do you agree? You get very thin.
128. 156.
Yeah. So so if you notice the size, this will be just 1. Can you see this is 1? There'll be the half. Can you see?
Yeah.
There'll be the quarter. There'll be the this one. Okay, that's eighth. That will be the 1/16.
132.
32. So how many times did we cut it? So this is number of cut. So number of cut. This is the number.
Oh, that's we only cut it 6 times.
Of halved. Halved.
We actually only cut it in half 5 times.
1, yeah. 1, 2, 3. Let's just I write down here. So that is n. 1, 2, 3, 4. It's just 3 times, okay? 3 or 4 times, 5 times, right? 5 times, yeah, that's right. 5 times. Yeah. Now, give you a chance to think it again. If we continue to this cut, what shall we obtain? Remember, this is not just not mathematical straight line. This is just material. Could be gold, could be timber, all right? So think about it. What shall we obtain? We just do what Democritus had done many thousand years ago. So what would we obtain eventually?
Something really small, atom.
No, we can count. Can we cut? Can we cut just continuously?
No, we can't cut continuously.
Why?
Well, wait, no.
Pretend you don't know. You pretend you didn't know atom. All right. In his time, nobody knew, including himself, if there's atom or not.
Yeah.
Okay. If this is mathematics, another thing, if this is a straight line, if this is just mathematics, can you see the 2 issues? If this is not a physical rod,
yeah,
it's just mathematical ideal, mathematical straight line. What would be the case? So this is a rod, or could be rock, and this is just a straight line. This ideal straight line.
Yeah.
We still got these lengths. Can you see? The lengths will be the same, isn't it? The lengths, yeah, the lengths will be the same. Now, can we just write a formula here? For this one, can we write as 1/2, 1? How can we rewrite this as a power of half?
1/2, 2.
Yeah, square. Can you see?
Yeah.
So that's continue until if after n times, what would be the length?
Half to the power of n.
That's right, half of power n. Okay, so this result is still the same for the straight line. Okay, for the mathematical straight line, there's nothing there, so you can cut continuously. So what would be the final length? What would be the n? How about n? How about n approach to infinity?
Then that's nothing.
Nothing. How to denote nothing in mathematics?
Well, it's not zero.
Not
Oh,
zero.
It will be zero.
It will be zero. For the straight line, you got zero. Okay.
Yeah, if it's
But-
infinity.
But for material, you get atom.
Wait, but can't you split an atom like nuclear fission?
Sorry, can you say it again?
You can split atoms, right?
Well, nobody knew. So you have to follow either Democritus' idea or Platonicus' idea. Platonic idea is that you can just cut continuously. In the end, you get nothing but the shapes, Platonical sonnets, which is just geometry elements, right?
Yeah.
So this is very much how you know depend on which side you agree with, okay? With what side you agree. There are two separate ideas, okay, different ideas. One believes that everything will be continually cut. Eventually, they got one of these 5 elements, right? And they have these elements have no substance but a mathematical shape.
Yeah.
And if you have very super microscope, then you should be able to see this symmetrical shape. Can you see? They are all symmetrical. Do you agree? There are 5. They are symmetrical. It's a very important idea.
Yeah.
Symmetric. That's something we can talk about. Why symmetrical? Do you think? Why do they always choose a symmetrical shapes?
Oh, because they can like fit onto each other to make patterns or something.
They are stable. No, they are stable.
Stable, yeah.
If it's not straight, is not they consider it should be not. If not, they believe that every such element should be symmetrical. You know, otherwise they cannot be stand alone by themselves. Okay. All right, story is now, but I hope this way of the conversation will help you to understand how people actually build the how the atomic idea eventually had been accepted since ancient time. Okay, so don't just open your textbook and say, oh, how many atoms you can count. You learn very little, right? You learn very little. All right, shall we continue our talk next time now?
Yeah, I gotta copy the pages.
You want to save these pages, okay?
Yeah.
Yeah, we discussed chemical and how to record the chemical.
Okay, yep.
Okay, second page. Second page is the elements. Oh, not is this second page? Second page. Yeah, that's second page. We mentioned elements in mathematics, and then from there we mentioned Platonic sonnets. There are 5 of them. Okay. And then we discussed that 2 types of geometry and Euclidean or non-Euclidean geometry. And then we talk about that Platonic sonnets are just hypotheses, ancient idea. Okay. But more importantly, we talk about Democritus' atom. All right. But remember, Democritus' atom is a hypothesis. Was a hypothesis. Okay. To realize, to actually to see the modern vision, you have wait until 1803 when John Dalton. Okay. We'll continue our story. When John Dalton first recognized that all chemicals are made by atoms. All right. That is many years later. Okay.
Yeah, that's right.
I will see you next week. Goodbye.
Yeah, see you next week. Yep. Bye.
Goodbye.
Thank you.
You're welcome.